Okay. So for my pencast, I was assigned problem 26 on homework 2, and the problem says that we're given this graph, and it says the graph shows vectors a and b, and we need to find vector d, which is equal to 2a plus b, the vector v. So this is what it specifies is this 2a plus b. And then it says write your answer in component form. So in order to do this problem, there's a couple steps that I decide to do first. So first things first is in order to get vector d, which is going to be the combination of a and b, we need to separate the components for a and b. So that means that component a and component b are needing to be separated in their I and j components. So vector a is going to be a with the I component plus a with the j component. And the same thing with vector b. Right? Okay, so basically this and this corresponds to the x and this corresponds to the y component, but for some reason, arbitrarily, they're I and j. So from here, what we need to do is to find these components, we need to use trigonometry. So what I decided to do is, I'm going to write down what sine and cosine are. So sine is equal to opposite over hypotenuse, and cosine is equal to adjacent over hypotenuse. Okay. These should be the sine of theta. So I need to redraw that real quick. Sine of theta, sine of theta. Okay, so we are given the distance for the hypotenuse for both of these, which is 2 and 4 meters for the vectors, right? And then the theta is given to us as well, which is 15 and 15. So the next thing we do is, in order to get our components, we do step 2, which is going to go and isolate one of these. So I'm going to do component bi. So bi is going to be using the okay, so since our I component is going to be the x, it means we're going to look to the adjacent side, which means that we're going to be using cosine. Cosine. So cosine of theta, which is 15 degrees again, is going to be equal to adjacent, which is what we're looking for. So I'm just going to put that as I over our hypotenuse, which is 4 meters. So 4 meters. So in order to get our answer, we're going to just do cosine of 15 multiplied by 4 meters to get our I value for b. So this is going to be vector b, I. And we're going to do the same thing with all the other components. So bj is going to be equal to the sine of 15, because we're looking at the opposite. So if we look at the angle, we look opposite, and this is our y component. But notice that the y component is going in the negative direction, or the negative y, so this sign should be a negative. This shouldn't be confused with inverse. It's just negative. For clarification. So I'm not going to write out this step again. I'm just going to be using the actual hypotenuse over. So since we can see that the hypotenuse is 4, again, we're going to multiply by 4, and that should be equal to our j value, right? And then we can do this with vector a as well for the I and j components. So a and j. So what we're going to do is we're going to look at another triangle, and this is going to be positioned in a little different way so that our sine is actually going to represent our x, because we look to the opposite side, and the opposite side is our x because it's going in the x-plane. So what we're going to do is the sine of 15 degrees, because again our theta is 15 degrees, and then we're going to multiply that by the hypotenuse, which is 2 meters, and we're going to get our AI value. Right, and then we're going to get this j value by looking to because the y component is to our adjacent side, we're going to use cosine. So cosine of 15 degrees multiplied by 2 meters is equal to the AJ component, right? And when we do the math, we get that the BI component is going to be equal to 30.86 meters. When we do the math for the BJ component, we're going to get negative 1.04 meters. Again, that negative is coming because we're going into the negative y field, right? And then we're going to go and look at the other numbers that we get for A, I, and J components, which is going to be for J, we're going to get 1.932 meters, and then the AI component is going to be 0.518 meters. We'll just do significant figures at the very end. So now that we have all of our A components and all of our B components, we can just bring all of these values together and look at the given D vector. So specified by the problem, it's not the D vector is not equal to A plus B. It's the D vector is equal to 2 multiplied by A plus B. So what we're going to do is we're going to have the D vector is equal to 2 multiplied by the A components, because these together are, as we visit this again, A vector is equal to A J component plus A I component. So what we're going to do is put these components in here. So A I plus A J component, right? And then that's going to be added to the B components, which is going to be the B I and the B J components. Okay, so I'm just going to substitute in the values real quick that we had from previous example. So what we get for AI is 0.518 meters. I'm just going to put an I here just so that we remember that. It's be key later. AJ is going to be, this J is going the wrong way. I do that sometimes. Sorry for making that error. AJ should be 1.932 meters, and again I'm going to do the subscript so that we will know this later on, and then add that to the BI component and the BJ component, which we had from before as the BI being 3.86 meters, and then we are going to get the BJ component as a negative 1.04 meters. You can write this as being subtracted from the I component, but this is just the way I did it here. This is necessarily the same thing as this, being subtracted there, but these values can't be subtracted or added to each other because they are different components in different fields. So this is representative of X, and this is representative of Y again. So what we do once we multiply across and do our basic algebra, we're gonna get the D, which is equal to 2 multiplied by those X and Y components, so J and I components, and we're gonna get a 3.864 meters for the J component of A, and then we're gonna get 1.036 for the I component for A, and then we're going to add that to the components that we got for B, so that's just going to be the same because we're not multiplying it by anything. 86 meters I minus 1.04 meters J. Okay, and now we have to rearrange this because we can't add all these values together because they're different, right? We have i's here, so those are going to be added to each other, and these j's are going to be subtracted from each other because, again, this was into the negative y field. So what we're going to end up getting for our total components are going to be 2.824 meters for the j component and 4.896 meters for the I component for D. So this is not where we're going to end. We still have to go to our other steps where we have to actually find the d vector in its entirety. So for the distance, since these are x and y components, this isn't representative of the actual magnitude of the d vector. So what we need to do is we need to use the Pythagorean theorem. So we're going to do d squared is equal to the j squared component plus the I squared component, right? So what we're going to get by doing math again, algebra, is we're going to get rid of the square, we're going to have to put this into the house. I can't remember the name right now for some reason. So that's going to be 2.824 squared plus 4.896 squared in meters and in meters, right? So what we end up getting for that value is d is equal to 5.65 meters, and this will be our vector's magnitude. And since we see that these components, the I and j components, are positive, they should be in the first quadrant. And in order to find the angle at which this is going, we're going to use some more trig. So in order to distinguish the angle, I'm just going to use the sign of whatever this is. I forget the moment what the name is. But the sign of the angle of a vector d is going to be equal to opposite over hypotenuse, remember, again. So the opposite value in this case scenario is going to be, if we revisit our triangle and say that this is vector d, right? It's going to be here, and when we look opposite, that's going to be our y component. So we're going to look at what our y component, and our y component is the j component. So we're going to have the sine of this thing is equal to 2.824 meters over the hypotenuse, which is what we just found, which is 5.65 meters. And in order to isolate the angle, we're going to do the inverse sign. So angle is equal to the inverse sign. So now in this case, this negative sign is supposed to be representative inverse of the 2.824 divided by the 5.65 meters. Sorry, a little messy. 5 meters. And the answer that we end up getting for the for this is going to be equal to 29.98 degrees. So that will be the 29.98 degrees, and that means that our d vector is going to have a magnitude of 5.65 meters, and it's going to be adjusted 29.98 degrees off of the positive x-axis. And that should conclude this problem.